Trees are like fingerprints. No two are exactly alike. Yet, like people, trees of the same species exhibit a number of common characteristics. It is this commonality that enables a timber like Radiata Pine to be graded with a high degree of accuracy. Structural Radiata Pine may be graded in one of three ways. It can be proof graded, mechanically stress graded, then visually checked, or simply visually stress graded. Proof grading involves the application of a predetermined load to a piece of timber. If the timber breaks, it fails. If it remains intact, it meets the grade. This is a destructive technique which can result in many broken pieces of otherwise usable timber. Mechanical stress grading is non-destructive. It tests a piece for stiffness, and because there's a relationship between the stiffness of a piece of wood and its strength, is widely used to accurately predict the strength of individual pieces of timber. Also widely used, visual stress grading is the more traditional method of grading. It relies on a visual assessment of timber defects, such as knots, their size and position, to determine the strength of individual pieces of timber. As visual assessment is not as closely related to strength as the stiffness test through mechanical testing, visual grading is the more conservative method of grading. Strength in timber is designated in a form such as F5 or F8, meaning the timber has a basic working stress in bending of approximately 5 or 8 megapascals. Radiata pine with a grading of F5 is suitable and commonly used for all types of structural members. Timber graded F8 is suitable and commonly used for trusses, glued lamination and framing. The visual grading of Radiata pine is carried out to the requirements contained in Australian Standard AS 2858 1986, which applies not only to Radiata pine but to all softwoods and cypress pine. All timbers have imperfections such as knots, which weaken the timber to a greater or lesser degree. Each imperfection is judged according to its size and location. Here's a piece of scantling. The wide surface is the face, the narrow surface is the edge, and the line where they meet is the arris. If we draw two equidistant lines along the face parallel to both arises, we have two equal margins and a centre. The width of the margins is related to the grade into which the timber is being sorted. The higher the grade, the wider the margins. A grader naturally doesn't draw lines on each piece of timber. The lines are visualised. For grading purposes, there are only three types of knots with logical names. They are edge knot, face knot and other knot. Here's a typical edge knot. It lies within the area between the arises. This is a face knot. It lies between the imaginary margin lines which define the centre of the face. There are a number of other knots, and for grading, that's what they're called, other knots. If they're not edge knots or face knots, they're other knots. Here are a few of the more common other knots. This starts on the face, goes through the piece, and emerges on the edge. It's also known as a through knot, but for grading, it's not an edge knot or a face knot, it's an other knot. Here are two examples of other knots that appear on both the edge and the face, splitting themselves across the arris. Being neither an edge knot nor a face knot, they used to be referred to as arris knots, but are now classified as other knots. And so, with three knots to consider, the next step is to classify the size of the knots as a knot area ratio, or KAR. This is the ratio of the projected cross-sectional area of one or more knots to the cross-sectional area of the piece. In essence, it's how much less timber there is because of the presence of knots. Naturally, the larger the knot or knots and their frequency, the more space they take up. That leaves less of the timber, so the weaker the piece. In Radiata pine, the allowable proportions for F5 are face knot 60%, edge knot 66%, other knot 45%. What the grader determines is whether the piece has more or less than the allowable proportions of knots overall. The simplest method of grading uses the go, no-go system. Take this other knot. Is it larger or smaller than 45% of the piece? Obviously it's smaller, so it's go, and the piece would be graded F5. providing there are no other strength-reducing defects. Here's a more complicated example. There are actually two knots here, both being other knots. As mentioned, for F5 grade, the maximum knot area ratio for other knots is 45%. If there were other knots in the piece, knots with this amount of cross-sectional area, they would probably create a no-go situation and prevent the piece being graded as structural timber. These are knot clusters, that is, two or more knots grouped close together, and they're measured as if they were one large knot. The knots in this example, not so close together, are a knot group, and their combined area is added up. Surprisingly, there's no such thing as variation in quality of knots. All knots are assumed to reduce the strength of a piece the same as a whole of the same size. After knots, the next most important strength-reducing characteristic is sloping grain, the ratio of the deviation of the wood fibres from a line parallel to the arris to the distance in which this occurs. A grain detector is a good device for determining grain slope, though in practice, and when grading fast, visual detection is used. Visual detection is made easier if resin ducts or surface checks are present, as these always run along the grain. Local deviations of grain around knots are not assessed, as these are taken into account in the measurement of knots. The centre of a Radiata pine log generally contains wood of lower density than wood from the outer part of the log. For the purposes of grading, wood from this central core is referred to as heart-in material and is defined as material which contains growth rings of radius less than 50 millimetres. To restrict the amount of low-density material included in the all-purpose structural grades, limitations are placed on the maximum width of growth rings in this central core region. Here, a band of early light wood and a band of darker late wood makes up one single growth ring, shown here as X. Warp in timber is a collective term to describe bow, spring, twist and cup. These may be present singly or in combination. Bow is deviation from straight when we look along the face of a piece. It is therefore related to thickness. Since the same amount of bow is easier to remove from a thinner piece than a thick piece, particularly when being built into a structure, it is permitted in greater amounts in thinner stock. Spring, on the other hand, is seen when we look along the edge and so is related to width. The narrower the width, the easier the spring is to remove. Twist is a deviation flatwise and edgewise at the same time, which tends to make a piece curl or spiral like an aeroplane propeller. Other imperfections include the occluded branch stub, caused when a branch has been pruned or died and fallen off. In F8 and higher grades, they're excluded irrespective of size. Wane is the presence of the original underbark surface with or without the bark. It is limited by considerations of appearance as well as requirements for bearing and nailing. In this slide, the top example is a resin pocket, the lower a bark pocket. They are not greatly strength reducing unless of a significant size. We have broadly covered the techniques used in visually stress grading Radiata pine. The end result is Radiata pine, which meets the standards for which the timber is intended. As well as structural grades, Radiata pine is used for decorative panelling, furniture, outdoor furniture when treated, and decking. Further information on visual stress grading is contained in the RPAA Grade Rules book, copies of which can be obtained by contacting the Radiata Pine Association office at 10 Pitt Street, Parramatta.